This is AP Calculus Unit 1, Lesson 2. We're talking about limits to a point of a function. So where are we in our unit guide? I did print these out for us yesterday. Thumbs up, thumbs down. I did do this? Okay, perfect. Yeah, so we are right here today. We're still on standard B. We don't get until the next standard for a while. I think this is going to be on Friday if we are on pace. So yeah, some more limits today. We have the setup correctly copied down, and we're going to knock it down. So evaluating limits. So yesterday we did just to a point, but now we're doing with functions. So a linear. Give me an example of a linear line, arrow, or bend.
Y equals 2x.
Y equals 2x. And arrow, another example of a linear line. Linear equation, rather.
X equals 2.
Yeah, that would technically be linear. I think it would be more of a constant, but yeah, that works. I'm going to do an example, x plus 2. Let's see if we can make that graph on our own. I'll give you guys 20 seconds. You might have to make some lines of your own. All right, do we get that function? X plus 2. You can check up on the board. Perfect. Quadratic. Give me an example of a quadratic. Arrow.
X squared
Yeah.
plus x plus 2.
Yeah, sure. That's quadratic. Ben, another example of a quadratic.
X plus 2 times the quantity of x plus 2 times the quantity of x plus 4.
Man, you guys have some really good examples. Okay, I'm doing ones that aren't as cool as yours, but I'm doing x squared minus 1. Both of those were quadratics, so thank you. Graph x squared minus 1, and you really only need to go out to negative 2 over here, and I can make this a little bit bigger too. You can go out to negative 2, negative 1, 1, and 2. I don't need you to go crazy. Okay, I definitely could have maybe done that better, but you can go ahead and check with my example to see if you got something similar. X squared minus 1. It's the parent function x squared, which is just that normal parabola shape, and then moved down 1 unit. So it goes all the way up to position 3 right here. This is 2, 3 at that point. Thumbs up, thumbs down. Got it? Perfect. Okay. And a constant function. Give me an example. What is an example of a constant function?
5.
5, yeah. So I'm going to do 4. Haha, one below you. Go ahead and graph h of x is equal to 4. Is it this way? Is it that way? Which way is it? H of x is equal to 4. So you should have gotten a horizontal line. It is a constant height. And I guess I should label that that is 4 right here. All right, so now I want you to evaluate the limit as I approach 1 from both sides, because there's no plus or minus over here. So as I approach 1, what is that equal to? Go ahead and give it a shot. All right, hold up the number of fingers. What did you get? 3, yes, that is correct, nice. And what does this thing mean? How do I read this? I can say f of 1, that's kind of dumb. What does it actually mean? We learned this yesterday. How do I read this, aside from saying f of 1?
The height at 1.
Yes, the height at 1. So what is the height at 1? Go ahead and list that also. What did you get for that arrow? 3. 3, perfect. So the limit and the height happen to be the same. Something weird happens when they're not the same. We'll talk about that this week sometime, hopefully. It might be next week though. Okay. Go ahead and try to find the next 4 answers over here, and we'll come back in about 2 minutes. So let's start with Ben. Limit of g of x as x approaches 2.
3.
3. Arrow, thumbs up, thumbs down. And then Ben, what'd you get for the height at 2?
3.
3. All right, Arrow, I'm going to give you a slightly harder question. Read this.
The limit of h of x. Let's see.
You're good so far? As Ben, you want to try helping her out? She has limit of h of x,
As x approaches -2.
Oh, perfect.
and then that last little bit, because there's nothing written here,
Both sides.
from both sides, exactly. All right, and then Arrow, what'd you get?
4.
4, and height was? Perfect. All right, so far so good. So the easiest thing to do when you're doing limits is just to plug in this number. Plug in that point to the function, and you get your answer. Does that make sense? All right, so that's the shortcut. And I don't even think I mean, you can write it down if you want. You can say that the shortcut is to plug in the point you approach. All right, so let's go to something a little bit harder. Piecewise functions. So limits of piecewise. Make sure I spell this correct. Piecewise functions. All right, so nod your head yes if you can visualize what a piecewise function looks like, either graphically or symbolically. No? Okay, so here's a piecewise function. F of x is equal to 2 different things depending on some conditions. It could be equal to x plus 2 if x is less than or equal to 1. Or it could be x squared minus 1 if x is greater than 1. You could have 3 equations, 5 equations. Just more than one makes it a piecewise function. So we're going to try to graph this thing. Okay, that's not what I want to do. And give yourself a bit of room. I want to do black here. All right, so when x is less than or equal to 1, so 1, I'm going to say, is right here, 1. Less than or equal to, is that left or right? It's left, and I'll write that up here as well, just in case we need that. So this is the left piece. And generally speaking, on the AP exam, they will always list the left piece first. Generally. I have never seen an exam, and I've taken probably 10 now, where they put the right piece first. So generally, it'll always be left piece first. And let's go ahead and graph that. So this is kind of like the barrier wall, and just graph x plus 2 everywhere over here. Give it a shot. Oh, I'm going to do blue now. Okay, so I have some questions for you both. What goes over here? Is it a dot? Is it a filled-in dot, a closed dot, or is it an open dot, or is it an arrow? What goes right here?
Should be an arrow, right?
It is an arrow, yes. And shout out again, what should go right here?
Closed off.
Closed dot. Why arrow?
Because it says there's an equal to.
Ah, yeah. So that has an equal to as part of it. That's exactly the reason. All right, go ahead and graph the second part of the piecewise function, the right-hand part. So this is going to be the right. And if you need a hint or an answer, go ahead and look up at the board. All right, so you should have a partial parabola. Remember the old parabola used to come like that, but you can't have that part because it has to be only on the right-hand side. So I cut off that part of the parabola, and this is the same parabola as we had over in our quadratic example. And what goes over here? Is it a solid point? Is it an arrow? What goes over here?
An arrow.
An arrow. And then what about right here?
Open
Open dot. Perfect. So things that we just want to annotate, that this was the left piece, so this was the top, this was the bottom. This was close. The reason I'm doing this is when you come back to these notes, you'll be able to remember what was the most important. The most important things from this graph are the things that are labeled. Closed and open. Perfect. And I want you to answer some questions about this now. So I want to know what, and I'm going to assume that all of this is still f of x. F of x refers to both of these lines and curves. I want to know what the limit of f of x is as x approaches 1 from the left. And it's kind of the same questions that we had yesterday. Limit of f of x as x approaches 1 from the right. And the limit of f of x as x approaches 1 from both sides. And finally, what is f of 1? And I'll have to move this up here. So there's really 4 questions, not 3. Take some time now to answer those questions.
X as x approaches 1 from the left.
Yep, and that is equal to 3. Arrow, agree, disagree?
Agree.
All right, Arrow, you're reading this one.
Limit of f of x as x approaches 1 from the right.
And that is 1. Agree or disagree, Ben? Disagree. All right, what do you think? 0. Okay, now do you agree or disagree, Ben?
0.
It is 0. All right. Ben, read this one.
Limit of f of x as x approaches 1 from both sides
Is
does not exist
D and E. Why?
because there's two answers and they're different.
Yeah, these both are different. And that's how you is because these are both different. The answer, you just write both of those. Perfect. And Arrow, read this one.
The height of 1 is 3.
Agree or disagree, Ben?
Agreed.
Agree, yeah. Perfect. Good job, guys. All right, we're on to our last slide. So our last slide is going to be when plugging in fails. And this is probably the rule that you're going to have to work to memorize. So when plugging in fails. And I just want to talk a little bit before I start writing. So far to evaluate these, literally we had to plug in 1 into each of these. A little bit less than 1, so plug in like 0.5 or something. This says from the left, I go plug into the left. 1 plus 2 is 3. You just plug them in. 1 from the right, I'm plugging in on the right. 1 squared is 1 minus 1, I get 0. Plugging into both the left and the right at 1, and I get different answers, does not exist. And then just plugging in for where it's equal to, 1 plus 2 is 3. All we've been doing is plugging in. This now is when that's not going to work. Here we go. This new limit. Limit as x approaches 2, and the function here is going to be kind of big, so it's going to take up some room here. It's going to be a fraction. So the top, the numerator, is going to be x squared minus 4x plus 4. Oh, giant parentheses. And the denominator, the bottom, is going to be x squared minus 4. All right, just like we were doing before where we were plugging in the point that we were approaching to our equations, we're going to plug in this number to the top and the bottom. So go ahead and do that. It shouldn't take too long.
Let's divide by 0.
Oh, Ben immediately sees it. So I'm not even going to do the top. I'm just going to do the bottom because that's where the problem is. 2 squared is 4. 4 minus 4. So we get something over 0. We have created a black hole. We have killed the universe. You can maybe write, I don't know, a face that has X's. He's dead. You have died. You have divided by 0. You cannot do that. All right. So what do you do? And this is a great chance to ask Sophia and Kaylin if they remember this rule. What do you do when plugging in fails?
I know.
Okay.
I know. You have to like factor out.
Okay. So there. How many steps are there?
Oh, factor.
Okay. We'll find them.
Cancel. Plug it.
And there they are. Factor. Cancel. Thank you.
Look how good we are.
Speed sheet number 5.
Plug in. So there are 3 steps. Factor, cancel, plug in. And I'll show you how those work. Oh, and I should make a note of this as well because I love shortcuts because it makes you go faster on the AP test. Whenever you have a fraction, check out the bottom first. And did you do that too, Ben, where you check the bottom first? Yeah, that is great intuition. So if you have a fraction, plug into bottom first. That will save us time. All right, so what I want to do now is to go through these steps. All right, Ben, factor the top arrow, you're going to factor the bottom. So this is now going to be, I still have to rewrite the limit. The limit as x approaches 2 from both sides, and then Ben, numerator, factors 2 what?
Hold on.
Okay, sorry. I'll give you guys some time. Do you have the bottom factored arrow?
Yeah, I think so.
All right, what'd you get?
X minus 2.
X minus 2 and
X plus 2.
x plus 2. You're correct.
And the top is x minus 2 squared.
Yes, that is correct. X minus 2 squared. Or I'm going to just write it twice because it makes it look nicer. So you should see that after we factor the numerator and denominator, and you can write this down for your notes as well, eventually you get these 2 terms that are the same, so you can do step 2. Step 2 is to cancel. And then I'm going to rewrite it just for the sake of looking nice in our notes, but on the actual homework, you don't need to rewrite it. You can immediately just plug in. So this now becomes the limit as x approaches 2 from both sides of x minus 2 divided by x plus 2, and we're taking the limit of that whole thing. So when I plug in 2, I check the bottom first because it's a fraction. My bottom, my denominator, is 4, so I don't have any more problems. Top 2 minus 2 is 0. Final answer, 0. And that's my answer. That concludes this lesson. Do we have questions before we write our summaries?
Can we say goodbye?
You can say goodbye if you'd like.
Goodbye.